Can everybody hear me? Also in the back? I don't know. Okay, this is the obvious. Oh, I am somebody, and I have a live slides. Yeah. I was thinking today maybe I have to switch to 25 plus years. I'm really becoming old. This was, by the way, in the time that I was still sportive. That's a long time ago as well. But yeah, it feels good to be a front runner, whatever that means. Okay. So this talk is, well, I would argue totally different than the previous talk, what is to some extent more about technology than coding itself. Hope not to offend you. This one is really about the craftsmanship of programming, on how to write code that is easy to understand, to reason about, and to maintain. And I like to give you some extra tooling to make you a better coder. Okay. And well, Dax already stated this. Simplicity is everything. It's the prerequisite for reliability. So how can we make our code so easy possible, so easy, the easiest way to understand? And what I'm going to show you today, at least I hope I do, is providing you with single value objects to actually just achieve this. Make it easier and simpler to write your logic. Because code is about telling a story. There is some real life problem that for some reason has to be formalized in code that can be executed to guarantee that that process or that constraints are maintained in your computer. And we are going to use single value objects to tell the story. So what is a single value object? It's equal by value. That's quite obvious by definition. It's immutable. And you could argue that it's by consequence, at least on how you implement it. It's way easier working with it if it is. And that's also where in the title, where functional programming and domain-driven design combine forces comes from. Being immutable makes your life really easy. It's valid by default. It doesn't contain any rubbish. And when I first introduced this concept to some people, I quite often found out that people really have difficulties grasping this for some strange reasons. And that's strange because take a really simple example of an integer. If I have a JSON contract and I define a property as an integer, nobody will say, yeah, but what if somebody says hello world as a string as a response? Nobody wants to store that value. But my argument here is that you should do that for everything. If you have a single value object that represents a single bit of information, you don't want to store something that is not potentially valid. Yeah, it should be tiny. That is where the single comes from. So you should be able to store it as a scalar or primitive. Another scalar, but I like your way of thinking. And it's encapsulated. So we don't want to share the internals of our single value objects. And yeah, I couldn't state it better than he did. Encapsulation is not a goal in itself. It really helps us understand our problem. By using encapsulations, we hide some details that we don't want to be bothered with. Going back to the previous slide, simplicity is a prerequisite. And encapsulating helps us. It's a tool for understanding. Okay. Single value objects are, well, not really new. Already in 36, my mistake, somebody, this guy, Zeus, designed a system that used booleans and floating points. 36-bit, by the way, but okay. So what does it deliver using single value? So one of the main benefits, coming back to the previous slide, the simplicity is making your contracts more clear. This is a quite common contract, I think, for a lot of people who write their contracts like this. So the rest doesn't. Yeah. Or both, because this concept is not limited to APIs or the other way around. You can use it in both ways. But by applying the simple idea of single value objects, this can change. We can say, well, we know the constraints of an email address. We will not use a string, we use an email address. And in most applications where I'm aware of, date of birth is really a date only. Only in really particular applications, you need the minutes on one is born, and the ticks, I don't think anyone knows exactly which tick he or she was born at. No? Okay. And even this one, although you could already argue if money is a single value object, but the combination of the currency and the price really are stick together. Most of the time, it's not useful to have them as separate properties. Because, yeah, if you lose one of them, the whole thing can lose meaning. Of course, if you have a system that specifically is designed to support one currency, you could say having a currency in your money is overhead, but that's another debate. And I really hate this one, where the name of the property hints what actually is in there and how you should interpret this scalar. By having a percentage as a type, you first can shorten your thing. And you also know exactly what you're dealing with all through your application. Percentage, by the way, is my poster boy. I really like it as an example to show you, and it will come back in later slides, why using single value objects makes your code easier to reason. Okay. Yes. You can do that. There is a downside. And the downside is that having a proper percentage that does all the things you want it to do, like serialization and parsing and formatting, how are you going to apply that on all those different percentages that probably in this case only differ in range? Most likely, yeah, but you probably in both cases can apply them to an amount and then leading to a new amount. So it will be really a lot of effort to ensure, because again, your reasoning I get, you won't don't interchange them, but you also want to work them in a lot of code. It's not only data collection, but also processing. And if you want to limit your processing, in this case of a percentage, which comes with a lot of cases where you want to add it to integers, maybe to money, etc., that can hit you back in the face. So I think for those cases, you potentially want more complex validators, because you also can say, given some constraints, the range is different than another constraint. So, but in some cases, it might be worth it, and we come to that point later. Okay, units. And I'm going to start with a really, I assume, well-known story. Who doesn't know this story about that? Who does? Yeah. And no worries. But really, having units in your types and communicating them explicitly can help you, can prevent you from making this, well, in this case, $1 million mistake. Okay, so how can that look like in code? Let's assume we have something that is a meter. And here you have already an interesting idea. Let's assume you want to model something like this. Do you want your distance to be a distance and assume it has a unit meter? Or do you have meters and inches and can you add them together? And it really depends, I think, on your domain, if you want to build it like that and which choice you make. But still, if you multiply a meter by a meter, you want something that is meter squared. And that also means that the result of that garden variable cannot be added to another meter, because meters and meter squares don't get along well. And of course, if you multiply meters by meters, then you should get, well, something in 3D. Okay. This is an example that for most people is more likely to occur in production code. We have something in price and we have a discount. And well, that leads to a new price. But let's assume that we use it with money. And you could argue that if you use a plus operator to add the currency to, in this case, a double, then it leads to your money and then you still have your total. But given the real expensive example, if you do it like this, then you can throw a currency mismatch exception. And that would prevent a lot of issues because apparently that was not the case. And of course, you also then build things that say, okay, I have a money and I have a set of converters that can convert according to the current standings, dollars to euros and vice versa, and with or without extra costs. Yes. Run, first, run.
Well, what's the question? Sorry.
Thank you. So I'm looking at this, and maybe you're going towards this as well, but this is probably going to be a runtime error. Would we maybe even make the types even more like have a how do you say that, American money type? I'm so sorry.
Make American money great again.
Compile the best money. We have the best money, so we can have like a compile time error when you're trying to do this. What do you think of that?
I think in most cases, particularly with money, that's probably not going to work because it's probably user inputs that decide, I decided to model this in dollars or in euros. So you probably only know it in compile time, in runtime. So I think in this case, that will not help. But also the example of shouldn't we even go further and say this is a different percentage than the other percentage? That also you see tendencies in the domain-driven design world where they basically want a different type for everything. And in some cases that might help. The examples I use here are the more reusable types, where you say, okay, in all applications, I want money to behave like this. And I like all cases, I like to have percentages that, act like this and have this kind of operations that work in a, predictable way. Okay. This is another really nice example where single value objects and having them reusable, that's an important thing I forgot to mention earlier, can help you. Let's have this initials example. I think probably a lot of you have applications where people can provide initials, and you could argue if they specify any of those three cases, they refer to the same initials. And having some parser logic that actually convert all those three cases to the same value, and by then come the same by value and normalize the stuff, really helps. Who has ever implemented something for postal code logic in the Netherlands? Okay. And who then gets a string, thinks, okay, do I still have to remove that potential space that is in there? And shall I uppercase it because that might not have been done before? Well, that's what this is about. And that you also know, once it's when it's presented to me, I know this is the case, so I can all skip all that logic. We come to that back later, by the way. And here is my poster boy again. Note that officially in .NET, the first one will crash because you can format a double to string, but you can't parse a string that has a percentage indicator in front or at the back. But if I have a percentage, I want both to be the same. Because I know it's a percentage, and if it's not specified as such, I don't want this to be 125. Does it? 12,500%. I want it to 12.5%, right? Sure. Very, very good question. A very good remark. You might want to. So you want your partial, of course, also to understand globalization and saying, given the current preferences of the thousand and the decimal separator, I take that into account as well. But for simplicity, I let it out. But it's a really good remark. You can potentially should be able to provide a culture info, and based on that, do the things. And if that's not specified, use the current culture active on your system. Yes.
Yeah, I was going to ask about the comma versus the period, but then it goes into one of my concerns. Is okay, you're defining a type percentage,
Yes.
and you said on the bonus that you didn't want to go very specific on the different constraints that the bonus can have.
Yes.
Right. But then when you get into the localization, you're bringing a lot of logic that is not specific to the domain, but it's just specific like to the current culture. Where do you get the culture? From the request, the user, you get from the database, and then what should be a simple entity starts to grow in terms of
That concern when you're dealing with doubles. Concern you need to describe. Because .NET solves this for you.
Yeah.
So the only thing in this particular case that I have to do, that I have to have something that really looks like and behaves like single value object, like decimals, like date onlys, like date times, like integers in .NET. And they have an overload where they say, okay, specify your culture. And if you don't, we assume that the current culture is used. And you can just ask it by culture info current. So in this case, if this runs on the server without any culture installed, so you have just the default invariant culture, then this is the default decimal separator. And if you have a case where you say, okay, I have to store something like, or actually retrieve something based on user input, and I know they have different preferences, then you have to take it into account. But that's then because I am processing and normalizing my input. Because, of course, under the hood, the percentage does not have a string representation, but some number that I can do my calculations on. And when I format it again, then based on the culture that I have to use, that I have to apply to do the formatting, I will use my thousand and decimal separators. And thousand separators are not really common in percentages to have to be used, but they can be used as well. No question? Okay. Okay. Here's the other one. If we have normalization on the other hand, we have formatting on the other end. Well, these are this is the most important interface that Microsoft has on this. So you provide the format and a format provider. And since .NET 6, I think you also have the read-only span format as an alternative, and then you have the try format where you can write to a span of hars because of formatting of performancing reasons. But I think for most people writing business software, it's nice that you can do that, but you don't need it. It's not where you can save the day by just winning some milliseconds or actually microseconds by making your formatting faster. Anyhow, who has ever written something with, I have a stream size and I want to have it in megabytes or kilobytes, and then have to divide by 1,000 or 1,024 based on your preference? Yes, okay. It's quite a hassle. But if you write it once correctly, at least you hope you do, then it would be really nice if you can do it like this. And saying, okay, I want 2 decimals. I want to have, in this case, F in this interface is whatever is the best fitting size, or I always want it in kilobytes. And the nice thing is then also you can use, because you implement the iFormattal interface, you can say the file has a size whatever. It helps making your code easy to understand. You don't have that magic function that says, yeah, go from number to stream size, whatever. You just have it built in. And it makes this code way easier to understand than if here was a special method. Okay, validation. That's another really important thing, because all those single value objects are basically a subset of the scalar you build it on top of. Who has ever implemented IBAN validation? Okay, well, if we look to this, well, some of the details are left out because otherwise it wouldn't fit on the screen, right? But well, first of all, you want to normalize your input, get some dots, spaces, underscores, non-breaking spaces out, and then you can have a discussion how strict you are allowing those formatters to be there. Well, if it's null or empty, I go into detail about this empty state later. But if that's not the case, then I check if it's the normal pattern, probably, then if it's valid for the country, and if the country code is actually a code I understand. And then you have that modulo 97 logic that also should be correct. If that's correct, I return my new IBAN. And from that moment on, I have normalized IBAN where I can do my formatting on and stuff like that. And others will tell you, sorry, unparsable, not a valid IBAN. Which is also really nice to have, I can tell you, because the default format exception of Microsoft has no field to state which field was attempted to parse or to format. And in the library I'm going to pitch later on, which is actually the result of these IDs, I created this because it's really useful to be able to communicate which value was attempted to become an IBAN or an email address or whatever you are trying to represent. Okay. The anti-corruption layer, that's basically the outer border of your application. And as mentioned in that postal code example earlier, once something is provided in your application, you want to be sure from that moment on it's valid. I don't want to recheck over and over again because I don't trust my colleagues to have properly passed me the data I needed. Okay. So this pseudocode says, okay, I'm going to create a command, a database command in this example, I think. I get a date of birth as a date time, but I'm not sure if there's minutes or seconds in because I don't trust the person who provided it. So I do the .date. But by having a more strict type that really represents this, I don't have to do it. This is a lightweight example, but if we have an IBAN, at least remove the spacing, do the upper invariant because that might be forgotten or whatever. So, as you see, there are all kind of things that hopefully simplify your logic. But there is more. Given those three examples, who like to define the percentage in the first case? The second one? And the third one? Are you serious? Yeah. Yes. I think the second one is actually the reason why you want a percentage, because if you see it like this, you still have to debate, and everyone who ever have worked with applications using percentages as decimals or doubles have to debate, yeah, but for 13.6%, do I have to provide 13.6 or 0.136? This one is faster, but I also think it's easier to read. If you have basically a constant you want to define, okay, it's the most easy thing to read. and it really helps your code. You saw the example before. If I have money and I have to define it somewhere, then I think it really helps to have an over operator that says, okay, I can add it like this. Of course, you can also define a method with dot currency and then provide something. But in this case, I think this is the most neat way of doing it. Okay. I also like this one. I have colleagues who still think that this is hard to understand, but this is what you do with percentage, right? You have something and potentially want to add percentage to it or subtract it. And by implementing it like this, you really have, okay, I can add 10% to something. Now I have a question. I have 3 options. In this case, it's 3 slides. Do we want to JSON to do this, or to do this? Who wants the first? Oh. Who wants this? And who wants this? And the reason is actually the same as in the first slide, because if I get the model with a number saying 21, then I really need to know what was intended to understand, okay, if I want to calculate with it, I have to divide it by 100 first, because actually it is a percentage. This is a string. Yes, string, number. And I have people who have objected against, yeah, but then the other side have to have a parser that can parse this. Yes, that's the whole point. They have to understand that this is not some magic. This is really something we agreed on. I am going to communicate a percentage to you. Okay. Identifiers. Who has an application with, let's say, 5+ different identifiers all being GUIDs? Okay. Who have application with 10 or more GUIDs as identifiers? Who once worked in a company with more than 100 GUIDs as identifiers? Yeah, Exact has a GUID for everything, I can tell you. So how awesome would it be if you have just a document ID and just implement it like this? And then a document ID cannot be mixed with a file ID or whatever. Yeah. Then for identifiers, exactly. For identifiers, and there's another example that comes after this where this also is applicable, but for identifiers, you really want a different identifier for every type. Even if under the hood it's still a GUID, because you want to be sure that you don't, especially when you have methods where you have to provide multiple GUIDs, that you're 100% certain you never can mix them up. Exactly. Also, a really good reason to have something like that. So, and what I show here has been thought of before code generators become really first member citizens of .NET, because now you also can use generators. But if you have a generic ID as a struct, then you can do things like this, saying, say, I have an instance, a static read-only, so basically a singleton that actually does the behavior for me, and then the behavior does the compare, the equals, the toString, and etc. And then I have my ID for whatever, and with, and then I can state then with global usings that this generic should be referred to as document ID. Again, with generators, you don't have to do that. But, well, by having behavior, for a GUID, you can argue that is fine. But if I want, for instance, a different string that I first have to manipulate, then I just can specify in the behavior how that should act. but I still have a struct that I pass on. So I have that value object, that struct, on my stack when I work with it. So that's the reason to have the logic, where you also can have inheritance in logic that you want to reuse, that you don't have to re-implement it every time for all your different structs, as structs cannot be inherited and can not use inheritance themselves. In the IBAN example, you can say you have some tooling that can be reused by different parsers. But here it's really, and I come to another example that also basically responds on your suggestion, where you can say, okay, I have a more generic single value object based on a string, let's say first name, last name, where I want to only have to specify for my parser, this is the allowed regex, or this is the allowed min or max length. But in this case, you can argue that by default, I think using global usings are awesome, then it becomes easy to read. But let's assume, where is it? Yeah, here. Let's assume I have a file ID that is string based, where I generate something like this on my next. So then I can say, okay, give me a next, and it does something different. But also, when I'm dealing with those IDs, I don't want to know if it's string-based or GUID-based. I just want my ID. I don't want to be able to actually parse all this logic in there because it's not relevant to me. What again? I think just like GUID next GUID, you want to have a static. You don't want to initiate something and then based on that create a new one. So I think you want a static. And that's also a reason why those generics help you, because then you can say, okay, give me that under the hood private single instance that does the behavior for my struct and then does the heavy lifting for me. So that the struct itself is it's really technically a non-space consuming wrapper around my words on the stack that I pass through to applications. And here is another thing that was the next step after I thought, oh, I can do IDs. I can have a single value with behavior. This is really for ad hoc situations like family names or street names. Because if you think of it, you really potentially want to have constraints on them. You also don't want to potentially have them mixed when they're just strings. But their logic is too specific to validate putting all the effort into trying to get all the logic of the world correctly when doing it. Also, initials. In the Netherlands, for instance, it's allowed to have uppercase T and then an H for TO as one initial. But do you want to have that in there? Because then you also have to know exactly what kind of quirks other countries have and have to support that. But you still potentially want that logic to normalize it and to make sure that it's not just a regular string. And then this kind of structure comes in handy because you have that behavior you can build on. For instance, you can say, okay, it has a min length, default is 0, max length is still in max, but I can override it and then provide my behavior. My single value object is still that simple lightweight struct, but I have a behavior instance that can do this heavy lifting. And as a benefit, people using this can also not potentially add properties to it because that was not your design intention. Again, it was a single value object, a single scalar. Okay. Who has ever heard of the term primitive obsession? Okay. Because that is actually what we were trying to solve with the IDs and also with those ad hoc types where you say, okay, I don't want a zillion strings in my model, but I really want to restrict them and give them different meaning. Well, this is my definition, by the way. And the reason that is mine is not because I think I'm smart, but I was Googling it and I couldn't find an agreed on version anywhere on the internet. So that might lack my Google skills. So if anyone has a really good definition, say that's way better, please contact me afterwards. But I think that given the fact that it's so common and such a quite bad habit, it's really strange that there's no way of really normalizing described what it should be. There's also no Wikipedia page about it, strangely enough. So if somebody really likes to stop in on Wikipedia, primitive obsession is yours. Yes. Okay. So no model-specific logic is available with primitive obsession. So let's just get us through all the code bases. When I entered the company I'm currently working again for, so now 20 years ago, we had a burger service number logic. Who does know how burger service number works? I counted it. It was also the first single value object I built based on this story. We had in one application 6 parsers that tried to come up with a way to validate if it was correct. One of them was wrong. And some were string-based, some were number-based, and well, it was all a mess. But that's what you get quite often. And logic might be duplicated. Well, another reason why single value objects help you overcome this primitive obsession is because you can filter the operators available. We saw encapsulation is a tool for understanding and not the meaning in itself. If you have an email address, for instance, you don't want to be able to say uppercases for me, right? Because that may change the meaning, at least from the local part. And you also don't want to be able to concat some string randomly to it, because it is what it is. And by encapsulating it, you do. If you have primitive obsession and you just pass everything as a string, then you can do substring and uppercase and whatever you want to do, which is not valid. Also, different properties. If we take the IBAN as an example, you probably want to have a property that says, okay, tell me which country is in here, without me having to know, okay, toString gets the first 2 characters. And different methods like the generics and stuff. And without primitive obsession, you don't have type safety. The example of the GUIDs, product ID and, well, company ID were swapped. Now I get no results in my query. Okay. Unfortunately, there are also challenges, because there's no such thing as a free lunch. But the good thing is that keeps us occupied, right? The biggest trouble, at least if you model a single value object as a struct, and I think you should, because the single value objects that are default in .NET are all structs for good reasons, is that you have the default initialization. And I know of a project online that has analyzers that try to prevent you from analyzing their single value object structs as default values, but I can guarantee you those analyzers will fail at some point, because it's so native to what .NET does. Even a dictionary try get will get you that result, and there's no way you can overcome that. You have to check if there is something. So that means that your default value should have meaning. First slide, well, third slide actually. No rubbish. It has to have value. Oh, that's too quick. That means, for instance, if you have string-based stuff like IBANs, email addresses, you have to consider, okay, what if that struct is initiated with a nil string, because that's the default of a string. So if you have a struct wrapper around a string, what does that nil mean? The choice I made in my library, and I think that's basically the only meaningful value, is stating, okay, if that's the case, then my struct, my single value object is nullable by default. So I have an empty state. And the downside of that is that you still have to check always, even if it's required, if it's not the empty state, like you have to do if you have a nullable int or a nullable decimal. But there is no way to overcome the problem otherwise. For percentage, of course, you don't need it because the default state is 0, and 0% is a, well, pretty logical default state for a percentage or another, well, continuous scale number representation. Okay. Although XML serialization is slowly dying out, by the way, who's still using XML serialization in some application? Oh, it's really dying out. I today still had a call with colleagues who didn't know how to properly deal with an XSD schema and XML serialization. But the XML serializable contract has a read XML that is a void. So basically, I call the XML read when I have a single value object that does support XML serialization, and then I have to change the state of my immutable single value object. Okay, well, there is a way to work around it a bit, and this is what I did. Oops. Saying I'm still a read-only struct. I'm only accessible through the interface explicitly, and then by unsafe sref, I can update my reference. And this might seem dirty, and I have to admit to some extent it does, but there's no other way to do it. And Node time does the same thing. So I'm thinking that I'm covered. It's not my ID. It was suggested by another who actually made a pull request saying you should do it like this. That's because before I had read-only structs, but I did not have the read-only keyword because my compiler did not allow me to do the previous implementation. But again, this is work you have to overcome if you want to do it. Run, baby, run.
Thank you. So the parse method here is calling a parse method on my SVO right now, right?
Yeah.
And then this cursed unsafe sref this is just literally overriding its own memory with its new initialization.
Yeah, and the only reason, and so you can potentially abuse this by explicitly passing your single value to the XML serialization interface and provide an XML reader that does this for you.
Yeah.
And if people really want to abuse a mechanism in that way, I think good luck. I don't going to defend against it. But there is no other way. That's the downside. If you have if you have JSON serialization, thank the Lord, or whatever reason you believe in, you have since .NET 6, you have system text.json as a part of the core library, and then you can just use the attributes. Therefore, you, of course, it was not default, and you had Newtonsoft, and then you had to do a lot of extra stuff because otherwise people had difficulties doing JSON serialization for you types. And you don't want to ship Newtonsoft with a library for people that say, yeah, but I never use anything with JSON. Why do I have dependency on Newtonsoft? Yeah. But that became a better contract in itself, because then you can use a static saying, okay, give me a new instance given this JSON state.
Thank you.
User reflection to map the properties. I mean, security officer coming by and.
Yeah, but the unsafe is misleading in that sense that you can't break stuff with this. Okay, let me rephrase. If you have a model and I say, oh yeah, use those nice single value objects because it makes your contract more clear. And then that person does, I say, yeah, but now it doesn't XML serialize properly anymore. And I say, yeah, then you have to hook in this complex logic. It doesn't work out of the box anymore. I think your colleague will say, sorry, but I don't going to do this. This is not worth it for me. And if you have this, then you just have your model, you do save as XML with the default XML serializer, and it says, okay, I can do this. And the write XML just writes internal value, and that also works. And that is what you want to achieve here, that people don't say, no, I can't use your solution because XML serialization is not normal anymore. I have to do a lot of stuff to make it work. And then this is your safeguard. And then I come back, it's a challenge because you want people not to say, yeah, I'm not going to use it. Yeah, there's a small advantage, but this is all what I have to do. It's not default. I have to know it, etc., etc. And you don't want that because then nobody will adapt it. I know from first experience. I can tell you. Yeah, but for objects, you can't serialize to a string value. And I don't want, because I use that string value object in my XML in this particular case, saying, okay, yeah, but now I get some extra nesting to deliver it for me. I just want to take the IBAN, let's say the name is IBAN of the value, an IBAN tag, then the IBAN value, and then IBAN close tag. That's what I want. I don't want anything else because I think I'm fancy, right? You just want to have it like all other stuff. And for that, you need to do some dirty work. That's okay.
Wouldn't you rather have that logic in some kind of anti-corruption layer, being the XML document being a separate system, separate layer? It smells like model leak.
But you also have this for your datetime, right? And for your GUID, and for your integer and your decimal. Where's the difference?
Some things are easily mappable, but this is a very different type with different features. It needs to be mutable. But
your GUID is immutable. Your datetime is immutable. Your decimal is immutable. Your double is immutable. All your int-based types are immutable. Your enums are immutable.
Mm-hmm.
And the whole thing is, if it walks like a duck, when it stalks like a duck, it probably is a duck. And those types are not fundamentally different. That's basically the takeaway of my talk. So as a developer, I want to use them in the same way. Mm-hmm. And I want to have the same experience with those custom subsets of those scalars that I have for the scalars that are built in.
But that's a type, and this is, we were talking with XML serialization, that's behavior. And so
yes,
I would model that behavior outside the type in that case in some kind of anti-corruption layer, being that the data of the types are in a different system or different subsystem, being the disk.
But then I need a new model where my subsets are still the primitive types, unless they are built in .NET. And then I have to have an extra mapping where I can just provide it as a default behavior of my structs.
Well, that's a trade-off, I guess.
Exactly. Yeah, and you don't have to think about it. And the only reason that we are now having this debate is because in 2002, probably, when Microsoft came up with the idea, let's make the XML serializable interface, they didn't think about being read-only as much as they do right now. For a type of serialization that is becoming obsolete anyway. Okay, I like to go further. Is that okay with you? Okay. Well, JSON serialization, I already hinted to it. Thanks to .NET 6, we have a default behavior that if you want to adapt to that, works like a charm. You just specify your specific serializer on top of your type. And if you use it, you don't have to do anything. Just somebody has to provide your type with a JSON serialization attribute, and it works. But when I started this whole endeavor, now 12 years ago, JSON was new, and shiny. And there was only Newtonsoft basically that does something nicely. And as mentioned, I didn't want to ship it with a Newtonsoft dependency because I didn't want to have to debate, yeah, but we don't do any Newtonsoft. Basically, why do I have the dependency? So then I came with something that will not work with ahead of time compiling, because it really relies on reflection, with a convention-based contract. Because again, static immutability. So if a type has a toString object or an int or a string, whatever, something, it returns something, and it has a from JSON string and potentially a double or a Boolean if you want to have other JSON nodes supported as well. Then with one JSON serializer, it recognizes, hey, this type has my contract, I can serialize using these methods. And then it compiles something once, and then, well, you're happy to go. But again, this is only because of historical reasons. Who programs front end as well here? Okay. Yeah, well, I do sometimes as well. Another limitation, in this case, if you port this concept to JavaScript, is that you can't override equals. Because, yeah, it's not possible. And you want to have it value by, well, equal by value. So, yeah, then you have to come up with a way to implement equality, what in itself is not hard, but then you really have to tell your users, yeah, we use this special thing to handle some nice logic for you, but you have to call dot equals on it. And especially diehard front-end developers are shocked. Really? Are they saying then? Okay. So, long story short, building single value object is not trivial. It's hard. And reusage is limited, or there are no limitations on the primitive or lack of domain-specific logic operators. It might not be worth the effort. And I think that's what you have to keep in mind. It's really awesome if you have it, but all the steps you have to do to get there might make that you say, oh, not in this case. It's not worth it. Because you go to your product owner and you say, yeah, I really think I can make this really cool. Yeah, I need 2 weeks to build it. Yeah. Yeah. But then you have a solution built once, you can reuse it all over again. So then you have reusage of your effort.
I have a small question.
Sure.
Do you use a single value object for every object in the system? Would it not be the situation that primitive obsessions was replaced with some kind of single value objects obsessions?
Yeah, that's well, you can say that's an obsession. It leads to different problems potentially. In the company I work for, I have some say in where we're heading. Thanks. And I noticed that most colleagues are happy with the types I provide out of the box. And there's still a lot of string properties, especially the ad hoc single value objects. We don't use that often. So we don't have first name and last name properties or types based on that. Also because the applications we work on don't really have extra logic. So I think, yeah, then it's potentially not worth the effort. But percentages we use a lot, IBANs we use a lot. We also have something in our application that's an amount. Because the application I work most of the time with is a mortgage application. And it's really useful to never be able to mix things that should be an amount and things that should be a percentage, because it really leads to confusion. And also when you have other floating point values, it's really useful to say, okay, this is an amount, this is about money, and this is something else. But I see your point. If it really becomes, oh, everything should be that, I think you're missing the point. That's no. I wouldn't do that either. But if you think there is for some of your types a really good reason, that initials, for instance, we have as well, and I think there is space off. But Mhm.
Domain where you do the data processing, and sometimes you get some form which was filled in by the nurse in the hospital,
Mhm.
and then you can have like a different types of null values which they fill in your column, and like in .NET you only have like a nullable, which is, and then you get into this like discussion. You have like a first type of nullable, like null of a first type, of a second type, maybe like a few special cases as well. Do you put those special cases in SVOs? Like, how do you deal with them?
If I understand you correct, you how to distinguish between I don't have a value and I don't have specified a value yet. Yes. Well, one of the things that's in the library, I built all types, well, most types, actually all non-continuous type also have an unknown state where I can specify, yeah, this person will have an email address, but I don't know it yet. Different than an empty one. But if you go to forms, if it's not specified yet, and that is fine, I don't think from a data processing perspective, it's really useful to have a difference between, okay, it's not answered yet versus it is answered, there is no value. Especially because these are single value objects that really go about really small things like an email address, my IBAN, my date of birth, etc., etc. Where you have a long text and you can say, okay, as long as it's nil, it's not specified as string empty, it is specified as nothing. But then the question is, do you actually get the right response from your front-end application in this case that you can distinguish those cases? And do you want to have different meaning between nil strings and empty strings? I think that's tricky in itself.
So we have one more question, and I'm going to ask to maybe if we could do the rest of the questions with a drink.
Yeah, I'm rounding up, so for me it's perfectly fine. But
Okay. My last question was around not all of us are lucky enough to work in greenfields. So if you start introducing single value objects into an existing legacy application, and then you've got to deal with rehydrating stuff from the database that may have passed through before you put some validation on your single value objects, what kind of sort of patterns and solutions do you have in place for that? We're dealing with, you've got a nice new shiny single value object, but you've also got to deal with stuff coming out of the database that was there before you introduced it.
yeah, I had a debate before with colleagues, not surprisingly. The really interesting question is, if deserialization all data using your single value objects will lead to something that is not understandable anymore, what does that say of your data? What is the consequence of that not understandable data in your system? How do you want to resolve that anyway? If that in itself is not problematic and it should stay there as is, then apparently the data is not wrong. So you can't use a single value object that requires you to be different. And if it's a problem, then I think single value objects are a really good way to help you write a repair script to find all issues where the data is wrong. And then you have to, based on your application and based on the users and the customer, etc., to come up with a defensive plan how to convert that data. Yeah, I know once, and this is 17 years ago. Yeah, did I already mention that I'm getting old? I didn't have to do it myself. Thanks again. I had a colleague who had to convert a Lotus Notes application. Some people in this room were probably not even born when that became obsolete. And that was used for a lot of data collection, but there were fields that were officially allocated for phone numbers, but contain full addresses and remarks and other stuff. Then you have another problem, and with or without single value objects, you will not save the game. You really have to think, okay, how are getting people on board to make this horrible, not really proper data, well, sane again? Is that a nice shirt? Make data sane again? Yeah. Yeah. Okay. So here is my sale pitch. Oh wait, it's open source. It's free. I built a single value object library in .NET. I since 4 weeks also have a really limited TypeScript port, but yeah, I'm working on that still. It's called QWave, and yeah. I have colleagues who on purpose call this quaff just to annoy me. Yeah. But still make pull requests and do stuff for me, so I'm happy. This is what you get when you think, okay, I need something that is short, says what it does, but I'm not Queen, so Google will not make my name be used in front of what you would expect to get when you have a Google research. And QWave actually always returns my library, so that's a good thing. Okay, so it's open source, MIT. I never heard somebody who says, yeah, no, I can't use it because you have the MIT license. There's a NuGet package. Actually, there are more related packages as well, but don't get me started. It also provides some code generation, but not in the sense yet that you can say, okay, I have my first name or whatever, put on an attribute and it generates it. That's still the generic stuff. It contains a percentage, money, date, postal code. I recently fixed an issue with the, what was it? Malaysian postal code. It turns out to be 7 instead of 6 length. Yeah, exactly. But there are 160 countries in there that have postal codes, and I think the rest should be right. Nobody complained yet. Email address, and it supports the stripping of comments, display names, the mail-to prefix, IP-based domains, bodies in quotes, because apparently some people will have to have an ampersand in their local part, and other stuff. So I think it's quite complete. Also, if you ever have an email address, do it right or don't do it. And regexes are not suitable or validating email addresses, and they're slow. This one is on average 50 nanoseconds per email address parsing. It supports JSON conversion, type conversion, XML, iFormattal, and iComparable, and some other interfaces. I have to put the Nationale Spoorwegen in here. I found out recently they also use my stuff. Yay! Oh, I'm so happy. Okay, takeaway. SVOs give meaning to your code. SVOs can be reusable in most cases. They reduce primitive obsession, and we should be aware of SVO obsession. It comes with a cost. Sometimes it's not worth the effort. And as a side note, global using statements are awesome. Okay, questions?
Maybe we can do 2, and then the rest we do with a drink.
That sounds like a perfect plan.
I'm just trying to better understand it, so I'll try and do like a scenario question. So I imagine like we did this talk, and then you walked into the lunch hall like 2 hours later, and you heard me trying to recite what you just said by saying like, oh, that's basically just composition, and yeah, you can use records instead of structs. What would you say to me if that was correct or not?
I think records are really useful in a different case. Records are really useful if you have multiple value objects with multiple properties, where you need the structure, where those single value objects really really are about hiding the underlying value. Name the I1 again. I don't want to be able to directly access the string that's underneath. At some moment, I maybe want to call the toString that actually does that and potentially formats it again, because now I want spaces and I don't store it with spaces. Or I want non-breaking spaces because I want to have it formatted without being cut to the next page, partly. And a record, if I have multiple properties, I want to access those properties. And also when you use a record struct, which can also be useful, you have all the properties accessible. And that can be useful if you really want to have some stuff immutable on your stack and pass it to without having the overhead of creating an object and also having the equality out of the box. But it's a different thing. You even can say that you have records that contain single value objects, or record structs that contain properties that are single values themselves. Does that answer your question?
Yes, that's perfect. Thank you.
Yes.
I wonder about your experience with language features that support this. For example, I believe F# has these types.
Yes.
And in C#, I wonder if the record struct syntax would help you alleviate much of the boilerplate.
That's a really good question. The thing what F# does, and there are other languages that provide that logic, I also think it's in C++. What I actually say is you can have some types within the context of your compiler. So the compiler helps you, or actually the compiler helps you preventing making issues while within the scope of the application. So within boundaries of the application. This is about types that you communicate to other systems. Because if I say in F# or in C++, I have a currency where I put things together, I can't export that to a library and saying, okay, you can provide me that currency, because it's a construct only to help the compiler for the compiler to check what you're typing yourself. And this is really about, I communicate something. I communicate a percentage as a JSON string, having a percentage sign at the end. And because of, well, common sense, I use a dot as a decimal separator when I do it as JSON, and otherwise I do it differently. That's totally different than saying I have a percentage type within my compiler, and if I call it within my own code, I know how to deal with that. So it's a good start, and it's a shame that C# doesn't have that, but it does more, and to some extent something different. I can't count. Was that two? Or do we start counting at 0?
Thank you very much. I'm gonna quickly one.